Going to work on the Unit 3 portfolio together. So I hope you have all the tools you need to be successful. You've got your problems, hopefully, maybe pulled up on your screen. You've got some type of calculator. Now, I'm going to be modeling on the graphing calculator. So if you've used that before, that's great. If you don't have one of these, you definitely can use Desmos or use one of the other scientific calculators to do some of our calculations with. But I hope that helps you. So let's get started. For this problem, we are being told that bacteria is a pretty common example for exponential growth. And the table here tells us how many bacteria we actually have at the end of each hour. So, for instance, you can read this table by saying that after 1 hour, there are 32 bacteria. After 2 hours, there are 256 bacteria. And you get the idea. So, number one is asking us when we compare the number of bacteria in each hour, what is the number being multiplied by each time? Let me translate that for you. What that's really saying is if we take 32 and we multiply by some number, we get 256. If we take the number of bacteria we had after hour one, multiply by a number, we get 256. Now, we also would take 256 then, multiply by the same number, and get 2048. And we would take 2048, multiply by some number, and get 16,384. Now, you and I know the opposite of multiplying is dividing. So I'm going to go on my calculator. I'm going to divide 256 divided by 32. And that tells me that that number that's missing there is 8. Now, I want to make sure it's the same number. So I'm going to do 2048 and I'm going to divide it by 256 so that I see, yes, it is 8 that I am multiplying by each time. Now, number two then says, okay, what is the initial amount of bacteria? And I know I want to say 32, but this is not asking for after 1 hour. It's asking for time 0. So, my friends, my chart doesn't start at time 0, but I'm going to make it. So, bear with me here. I'm going to just add a little extra space to our chart. See, I'm going to add time t equals 0. And I already know time 1, 2, and 3. That's 32 and 256 and 2048. But what I don't know is this number. So remember, we're multiplying by 8 each time. So really what this question is saying is what number would you multiply by 8 to get 32? It's really what the question's saying. Well, if you remember your facts, or if you don't, you can remember that the opposite of multiplication is division. So I would do 32 divide by 8, and I'll get 4. So I know that 4 is my value for time t equals 0. Now, question 3 then says, okay, now that you've done that piece, I want you to put it together to write a rule for this table. Well, exponentials are pretty simple in that they follow a pattern. Now, don't get frightened by that because I want you to see you've already done the hard work, okay? The A here, we call that the initial amount. Friends, that is the amount at time 0. We did that in question number 2. We already found that value, and it was 4. Now, B, I bet you already guessed, we already found it as well. B is called the base, but it's really what we multiply each time. It's the multiplier. Well, remember back in part number 1, we already found the multiplier was 8. So now I have my equation, and I want you to be really careful. We cannot multiply 4 times 8. Here's why. 8 is going with the exponent first before it gets multiplied. So I have to leave it just like this. 4 times 8 to the x. I can't say 32 to the x. All right, I've got one more problem for task 1. Task 1 says, number 4 says, suppose you started with 100 bacteria that grew by the same growth factor. Write the function for this rule. Okay, so here's my function rule for exponentials. I remember A is my initial amount. So it looks like in this problem that A is my 100 because we're starting with 100. So A is my 100. It had the same factor. Now that's another word for multiplier. So I know that that multiplyer's got to be the same. Remember from part 1 what our multiplier was? You got it. It was 8. Yep. And there we go. We've got to put our x in there. We've got our y. And there's our equation. Now ask yourself, can I make that 800 to the x? Can't do it. 8 is going to the exponent, and then it's going to be multiplied. So we've got to make sure we leave them separate. All right. Make sure you watch the next video for task 2.